Hello. What about us this time? Mainly share the selection of connectors. Follow the relationship between some basic raw materials of connectors. This is a very, very important link. We mentioned earlier. What's wrong with the structure of the connector? What about structure? We talked earlier about conductors and insulators. But how do we communicate with our market applications? How do I choose my conductor? How do I choose my insulator? That's a very, very crucial component. Let me give you an example. Our current one? Industrial use? On this battery. 1 by 1, a high current connector. When the customer selects the model, what does he want? What he wants is simple. I want to achieve high power energy transmission. For customers, what he wants to achieve is energy. High power. Under the premise of this purpose, customers will demand implicit security. Reliable. These are its two core requirements. Under these conditions, how to achieve connection security? The safety of good electricity. We talked about the safety of electricity in the basics. That is personal safety. No leakage, or put this. The risk of voltage damage to the human body is reduced to no. I chose the connector. This connector. I ordered one. Optional working environment. In this working environment, how do I make my appliances work? Can it reach a safe level? The first one is the safe voltage of the body. Leakage current and leakage voltage must meet these requirements. So let's start with this. When an electric current appears, that current corresponds to my conductors. This one. Current carrying. Can my current carrying capacity be satisfied? And for current carrying capacity, in fact, for a stable material, the cross-sectional area of this conductor, the connector industry, we usually use copper or copper alloys. We call it copper alloy. Using copper alloy as a conductor. The conductivity of copper, whether it is from 10 to 20% of brass, to our zero copper, to the copper, 90%. In the process, its ability to conduct electricity and carry current. It makes a difference. So if I want to use a suitable one, in this established electrical environment, so which one do I want to choose is the most suitable? Usually, the choice of materials, except for my electrical properties. We have to think about it at the same time. The mechanical part. His mechanical abilities. Under normal circumstances, in our electrical connector, in the selection of materials, we usually put this male end. Will the female end be separated? Because the male end is usually a column, so the requirements of the male side are mechanical. Not very high, but the female end, because it's an inclusive body, so there's fatigue and mechanical requirements. That combines electrical conductivity with this so-called mechanical part requirement, so the female end. We are the lowest. Usually applies to requirements above zero copper. The above materials, brass is basically not there. The application for the female terminal will appear. Of course, there are cost requirements in some cases, even in some cases where the requirements are not high. If we're going to use brass, that will also use part of this additional structure to improve the lifespan of the material itself, or fatigue strength. The other part. When my conductor selection is confirmed, because considering this safety issue, earlier we talked about temperature. There is talk about this fever problem. So for this reason, when we choose the insulator, the first thing we have to consider is also safety. The safety of the insulator. That's ours. So that's on the insulator. There are a few key metrics. Surface resistivity or volume resistivity. It measures our insulating material. It is used in normal application environments. What about the insulation? We talked about that earlier. This creepage distance and this electrical gap. The insulating material is in this process. How to effectively protect? The strength of the protection depends on its surface resistance or volume resistance. What about our other application environment? It's not completely insulated. It may be because of, for example, the humidity of the air. Maybe because of some in this polluted environment with some metal dust. What kind of gold with some dust? So we're on top of the insulation. It has another name, leakage marking index. This is what we usually call CTI, leakage key hung index. It is the same to measure. I have this material. Can you meet my electrical performance requirements? A very important metric. How should this indicator go? How about we actually apply it? Then this is of interest. We will discuss it in depth later. Or share it. Here it is. Is there anyone who is interested? You can also search online. We also have IEC in this regard. There are also some standards. National standards also have standards. What about here? I'm just sharing with you these 3 metrics in our customer's selection and in the customer's application scenarios. It plays a very crucial role. The key is this function. Let's say some of our mines are used in underground mines. Well, some of these are more seriously polluted in some environments. Then we calculate this leakage trace index. His requirements are higher because he has some outside media. The influence of the media that under normal circumstances, we only need to consider the surface resistivity of my material or this volume resistivity. Basically, we can do this. This is for the safety of materials. What about this consideration? Let's talk about other things. We've talked about conductors and insulators. Let's talk about our last auxiliary key. From a security standpoint, conductors and insulators. It is an application that can meet the basic requirements of connectors. But the connector is a systematic project. It's not unilateral. I'm satisfied. There is no problem with the product. Then in the auxiliary key, we will have some such as this type of protection. There are some protective parts in the auxiliary parts. For example, it's called a shell. For example, some of this kind of protection. What about at this time? We also have to take into account this of these accessories. Selection of materials. How to achieve the safety protection of a pair of current and voltage. Here's environment 1 and environment 2. Like humidity. Like low pressure. Such a condition of protection? Therefore, in the selection of protective parts, we will also ask for, according to the corresponding state, choose the corresponding material. What about the specific choice? It will be different according to our actual application state. Like our outdoor environment. There's going to be some rain out there, right? This acid-based pollution, etc., etc. Or the indoor environment. There is a part of that. For example, this rainy weather in our south. The long-term temperature and humidity are very high, or some extreme in the north. In extremely cold weather, when your moisture appears, this is related to the condensation state of the material. Will it make the material brittle? And so on. These conditions. This is all as an auxiliary part. Protective parts must be considered. One by one factors? Well, from the perspective of selection, we need to communicate and discuss with customers. Maybe these things. Thank you very much.